And it takes courage to keep going. Right? It takes courage to be resilient. It takes courage to have something that you want to do. Right? To have a roadblock get in your way. And to keep pushing through. That's what we want you to do. And resiliency attached to that, which I think is nice. All right, mini thing from the other class. What is a tectonic plate? Let's see. Rosie, what's a tectonic plate? What's that? And what does it do? What's that large piece of earth do? I guess we'll find out. Number 2. Let's see here. What's up? What's up? Sophia, tomorrow, what does it mean to say a plate moves at a constant rate and direction? Don't need some help? Can somebody help out Sophia? Mariam?
They are going to the same direction.
Number 2, yeah. When we say constant rate, what does that mean?
Like they are going to the same direction and same rate.
Same rate, but what's a different way we can say rate? So when we think about a plate, we talk about movement, so it's moving, right? Same speed, same direction. So what's happening? Same speed, same direction. So that's the other part of the tectonic plates, that big piece of earth that's actually moving. Okay. What kind of data can show that plates are moving? Pablo Uribe. What kind of data can show that plates are moving? You don't remember? Rosie? GPS movement data. What is it, Pablo? GPS movement data. Amelia, if 2 places move in the same direction at a similar rate, what might that suggest? Number 4. If 2 places move in the same direction at a similar rate, what might that suggest?
They are on the same plate.
They're on the same plate. Perfect. Number 5. Why do we still need to use a cross section when we're exploring that idea?
And to see like how like the soil and everything like seeds or like acts.
Yeah, the soil and everything else is where? Below ground, right? That the cross section is a cut, right? So we see that. And number 6, depending on how many of you were here for that. What happens to particle motion when something warms up?
Faster.
It gets faster. Perfect. All right, here's our goal for today. We're going to be looking at patterns. We're going to be thinking about something called collide, slide, and spread, and how this all fits with Mount Everest. So don't copy. What do you think is the most important words? Abbreviate, but we should be in our notebook. Section 4.7. Let's go. You need to go get your notebook, or do you need to go use some paper? Let's go. Yes, Carl. I'll write it back. Okay, this is success today. So again, this idea of what is collide, slide, and spread. We're going to be looking at something called motion arrows to help you understand things. That we're able to say why Everest, it makes sense that there's collision happening. And again, we're going to be looking at that cross section. Here are our words today: collide, slide, spread, boundary, and mountain building. On your page for vocabulary for the unit, if you're running out of room, what makes sense?
On a page.
A new page. A new page. Okay, so try to get this all here. Remember, we're getting the term down and then paraphrase the definition. Don't copy it. Nobody needs to get better at copying. It's not a skill. All right, here's the definitions, and then again, getting over to the questions and trying to answer those No, wait, what? Yes. I don't have a pencil sharp. Anybody have a pencil sharpener for Molly? Okay, getting the definitions down, answering the questions. About halfway through. So we're supposed to know the answers, but we can't guess. It's just fine, you're exploring. Another 90 seconds. All right, so if we travel back and that didn't work out either. It's hard to find a really old map that blows up one. So we traveled back in time, like the 1400s. People who lived in Europe only knew about Europe and a little bit of Africa, right? They had no idea that we were here, or there was the Americas that were here. No idea. So when they made maps, they kind of looked like this. They had Europe, because they've been on the coast. They have a little bit of Africa. Nothing's that very specific. And then in the late 1400s, when Columbus sails to the west and accidentally runs into islands that he thinks are off the coast of India, right? He never knew that he found something new. We start getting more and more information. Okay, and so then people started making maps, and they kind of look like this because they were kind of sailing around and seeing things, and this is what's South America, this is North America. It's not all what it looks like in actuality. Okay, but that was the best that they had at the time. And then years and years and years of people sailing and people keeping track of stuff, you wound up getting a map that looks something like this. This is from the 1910s. Okay, so by the 1910s, we had a really good idea of what the world looked like. And it was at this point that somebody was looking at the map, and they were looking at it, and they were looking at it some more, and they're like, that's weird. They're like, that's really weird. This looks like it used to be here. So he had this idea, and he said, I think that like South America.
Yeah. Bien. Tu hermana le digo por ti. Chao, gracias. Chao, JP.
Enjoy the rest of your day. All right, so that was the idea. And so the idea then created this notion of things are moving, right? And so for decades and decades and decades, we had this theory of this idea that, we think things are moving. There was no real evidence or proof, right? And then you kind of fast forward to the 1990s, and actually, if we think about today, what did I?
Where are you?
Yeah. The Waze and the GPS. So we have these guys, and we were able to put these into the ground, right? And this proved, beyond a shadow of a doubt, that things were moving. Okay? And so this kind of spawned this whole idea of plate tectonics. So this is our best understanding of what's happening on the Earth right now, is that we have all of these different continents. And those continents, the different pieces, are on these huge tectonic plates. Okay, so if you look at South America, all of South America is on one plate. So that means, in general, all of South America is moving in the same direction at the same speed. Okay, all the time. Okay, the movement is never stopping. Okay, we don't necessarily feel the movement. How many, does everybody's hair grow? Does your hair grow?
Yes.
Do your fingernails grow?
Yes.
Do you see them grow? Do you look at them and stare at them and see them grow? No, so it's the same sort of idea. We cannot stare at the Earth and see all this thing growing, but after time frames, then we notice them, right? And we can see things are happening. Did you have a question or just relax? Julia, you had a question at some point. No. Mariana.
If I put I a stick on the floor and I wait 1 year, it would be in a different place.
I mean, yeah, but you would have to know, but everything is moving.
Yeah.
Do you see what I'm saying? You would have to have some. That's why the GPS is important, because it knows where it was. Okay, looking at it, you wouldn't be able to tell.
So what if you put spray paint?
With a spray paint remover.
So
Because we're all part of it.
on that photo, you're like you're bringing all the continents together. Yeah.
Am I bringing them together? Well, let's look. All the arrows are pointing in the same direction. So anywhere we see these arrows, anywhere you see two plates touching each other, we call that a boundary. What do we call that? 1, 2, 3? A boundary. We have 3 different types of boundaries. We have the arrows pointing towards each other. That's called colliding. What is that called? 1, 2, 3? Colliding. So they're rubbing into each other. We have arrows pointing away from each other. We call that spreading or spread. What do we call that? 1, 2, 3? Spreading. So we're spreading. And then finally, very few places we have this, where they're sliding next to each other. What do we call that? 1, 2, 3? Sliding. So we have collide, we have slide, and we have spread. Okay, so those are the 3 main pieces of the boundary types that we have. And those boundaries, again, are where 2 plates are meeting. Okay, you'll have some sort of action. Yes?
In ice one,
Here, you have different places that have a lot of different activities. So like Iceland has a ton of activity on it. Like volcanic would be a lot.
yeah, but in the map it shows
Right, some of it's on Eurasia and some of it's in the
Yeah.
Caribbean.
Yeah.
Yeah, that's why if you're over there's tons of volcanoes, there's tons of stuff happening. Okay, because it's on this midline. Great noticing. Okay, so what we now believe, okay, again, what our theory is that this is kind of what's happened throughout the billions of years of the Earth's existence. Right? We had land, it was all attached, it grew, and then it started to separate. Obviously, this is billions of years in seconds. Okay, but this is the best of our understanding of what's going on. And it'll continue to move. Okay, and in another billion years, things are going to look different. Okay, a lot different. Because every day, all the time, we have movement. What's up?
In 100 years, Colombia like South America can be so separate of North America.
Well, let's look. Which direction? South America, it looks like it's moving west. North America, here at least, is moving south and to the east. So are they going to combine again? Who knows? Right? But all we know is in a million years it'll look different. What's up, Rosie?
So, like,
Yeah.
in million years, South America could be in the spot that today is like Asia.
I mean, that seems like too far. I don't know.
Okay.
What's up?
It's for saying something.
It's for saying something?
Yeah, it's like for saying any part of the world.
What do you mean? I don't understand.
No.
Okay. All right. So let's look at the 3 different boundary types and what they do. So we had the first type. We have the surface. We have 2 plates. And these 2 plates are moving towards each other. And when they're both moving towards each other, we call that, oh, Pedro, do you remember? When they're moving towards each other? Collision, excellent. They're colliding. When plates are colliding, what you will get normally is uplift. And what does uplift cause? Do you remember? Not the earthquake. Mountains, okay? So a lot of times when we see mountains, we should see some colliding happening. So if we look back at our map, where we are, we have a ton of mountains here, don't we?
Yeah.
Are these 2 things colliding? Yeah. Over here is where Mount Everest is. Do we see collision? Yeah. So collision in general is going to cause uplift, which over millions of years, we're going to have mountains. Another thing that we might have, we have the surface. We have 2 plates. And these plates are moving away from each other. Isabel, do you remember what it was called when they were moving away from each other? Sliding is that they're going opposite. That's a good guess. It's the other one. It starts with S. Spread. All right, so they're spreading. And what's happening here is we're getting new land. All right, so if something is creating and something is pressing it apart, and that thing that's pressing it apart is land, a lot of times it's going to be seafloor, which just means the bottom of the ocean. So that's what's happening. We get something that's spreading apart, and so we get new ocean floor all the time. And then last, was what Isabel talked about. I don't know how to necessarily draw this as a cross cut.
Like you can.
So this is drawn as a bird is looking down. It's like up above. I haven't figured it out yet. So we have a plate here and a plate here. One is moving this way and one is moving that way. And again, we call that slide. A lot of times you're going to get a lot of seismic activity or earthquakes along this type. Okay, so if we look back at where this one specific one is here. This is where like the San Andres Fault is. It's an enormous fault. Tons of earthquakes are happening. Okay. There's some others around Japan. There's not a lot on this map. I think that's the only one. So when you're doing work, focus on this area when it comes to this slide. Mariana?
The ocean also have plates.
Yeah.
And
Because look, what's this part of the South American plate?
ocean.
All right. So in general, the Atlantic is getting bigger and the Pacific is getting small. Okay, every day.
What do you think like in billions of years South America will be?
I mean, in my head, it's just everything's going to meet on the other side, but I don't know. Because like you have Pangea and then you separate and you come back together.
Is it right? Like plates like in that.
Can they join together? It's a great question. I don't know. I mean, that's colliding, right? And so at some point that might stop. I don't know. Again, I haven't been around long enough. Huh? What's up?
No.
And again, this one is like a bird looking down. This is not a crosscut. Crosscuts and then from the top. So I can't figure out how to do a crosscut for that. Juan, what's up?
In the one of spray, what is seafloor?
Seafloor, that's just new ocean floor. So if you go to the bottom of the ocean, there's ground down there. And so you have new stuff coming up. Okay. All right, at this point, write down 3 things you remember.
And the answers of the questions are.
We haven't got there yet. I mean, we've covered them, but we'll go over them again. 3 questions before we leave. Someone else go to ask them, Sophia. Let's get some
Like for
new hands.
example, when you like, if plates move like I don't know how much years, but like can like so in North America change spots and be like closer to Europe.
Could be. It all depends on what direction they're going and how long we're looking at. How many?
Is it possible for a plate to go up and the other one go down?
When they're colliding, yes. We're not getting into it.
Instead of colliding, they just go like.
Well, there is certain types of collision where one plate will go underneath the other one, and then a certain type of landform is created, but I don't want to get into that right now. So yes, one is going down, the other one's going up. Huh? And come on.
Like when like in the Spanish place, like hits another with like land. Like they took a land and they are like in the their land. Why doesn't happen like a big disaster and they put like
So that's if if it's going fast, right? This is happening quickly. That would be a big deal, right? But if the theory and the idea is that it's moving at the speed of our fingernails or our hair, that's much slower, and so that's why these mountains are created. That's the destruction of these mountains over millions of years. Great questions. All right, at this point, we'll go on break.
Yes. No, ¿tienes agua? Oye, seguido, oye. No,
Eso te pegué cuando yo me pegó. Son contra el palo.
yo creo que eso está un poquito por.
Hay que hablar con mi vecina.
No le sé, depende. Hola, vos fuiste una de esas clases de estudiantes que perdí 2 años. Vos no perdiste años.
Ay, perdí los años. Yo sí. ¿En serio? Porque quieren poner esos tres estudiantes.
Uno de esos soy yo.
Y los otros dos, no sé. Tengo 2 años en 3, 24. ¿Qué?
El diablo. Vamos como normalmente te dan unos ensayos.
Porque estamos bien. Me llamas con Pablo y Lorenzo.
¿Hola?
Me llamas con Pablo y Lorenzo. Ellos tienen unas dosis.
Voy a poner un montón de fotos. Y yo también banderas. Y gente en grado. Enterramos a una persona en grado. A ver si sobrevive.
Mr. Laga did a math and with the 31 minutes, without counting the 10 minutes that we're going to use to trivia and the minute thing, we're going to use this for 21 minutes.
Work time.
What?
You're about to find out the
of
same
what?
thing that I worked on.
Model or don't tell me the thing of level 1, level 2, or level 3.
Yeah.
What? We never finished it.
Huh? You got time, you can do it.
We never finished it.
But it's about doing the work.
We finished at least level 1 or level 2, but never the level 3.
It's fine.
Or even when times
I don't want you to have free time where you're just sitting around not doing it.
Yeah, I prefer 10 times a model than the whole thing of levels.
But usually there's a model involved.
Yeah.
All right, so this will be the level work today. Level 1, I'm asking you to make a very simple map. Okay, don't go too involved. It doesn't need to be a work of art. Okay, you're going to be using the map here. The map here, you need to have all 3 of the different boundaries that we talked about. What the difference is you need to label it with the correct plate. So if you look on the map, all of the plates have names. Okay, so you need to find one of each boundary and draw a very simple map. Okay, it doesn't have to look perfect. That is level 1. Level 2, you're creating a claim about what boundary do you think it makes sense that is next to Mount Everest. Okay, so what boundary created Mount Everest and why do you think that? And then level 3 is we're adapting our slow model. Okay? So we now have more information about how mountains are created, and so we need to add that to our slow model. So again, level 1, making a simple map. Instructions are here. So when you go, I don't understand anything, I'm going to ask, like, what direction are you reading? Right? Because we should understand. So, Rosie, can I help? Abel, what's up? Throwing stuff. Abel, we did not. So, but see that what happened? You get the reputation for throwing things, right? And then people think you're doing it. If there's that time you're throwing a bunch of stuff, now people just think something throws, then it's you. But, yeah, that sucks. Let's move on. Level 2, again, a claim about what makes sense when it comes to Mount Everest. And level 3 is updating your slow model. What is level 1, Maya? Level 1, what's the expectation? You weren't paying attention. Julia, what's the model? But now you gotta pay attention to Julia. She's explaining to you. Well, more, yeah, I mean, you're doing a simple map, okay, of the 3 different types of boundaries. So what is it, Amalia? Of the boundaries. We have to label the plates, okay, label the plates with the correct thing. Level 2, Abel, what's level 2? There we go. Why was it Mount Everest created? So what is your claim about the boundary that's near Mount Everest? And then Juana, level 3 is what? Okay, awesome. All right. So any questions about that work before we begin? No, you're at your desk. It's easier for me to look at your work and walk around and I can take notes because you're sitting where you're supposed to be sitting.
One day we can.
You're welcome. I don't know, the next unit. The final will be after. The final of this unit. That's why mid-unit is Wednesday. Wednesday we have a assessment. The following day E you have an assessment. The following day E you have an assessment. There's no surprises. Everything's on sewer. Yeah, every assessment you take is part of the process to show your understanding, learning, mastering the concept. I look at it and they give you a grade. What do you work with? Sure. Sure. Yeah. Great. It'll affect your summative grade for report for this year. Because this will be the second assessment you've done. So we should be showing mastery. Martine, how can I help you? Martine, how can I help you? Turn around and do your work. What's that? You're finding all three boundaries, but you're actually labeling it with the correct plate name. So you're not just saying plate. No, you always do the notebook. Alright, so this is a map. It has arrows on it. When they're pointing together, what does that mean? They're colliding. So I could draw South American plate, Nazca plate, that's my colliding one. Then I need to find one that's not colliding. I can look right here. Oh, is that one colliding? No. And then we have sliding. So you need to find the three boundaries, but you need to write the actual plate names down. That's what that means. It's both, right? Those are the plates that are direct. Both plates, because it's two plates. Try something, I'll give you feedback. Try something. Huh? Try it. Let it. I'll tell you what's right. No, just try it. Who cares if you get it wrong? It's not going to affect anything. You not trying something that affects stuff. You have to train yourself to try, because it's just practice. And then I look and I go, yes or no. If it's no, you try something else. It's very straightforward. Cool.
And when you cannot combine it, I just think I'm
Just remember to say what it is. But why are the arrows pointing away? What kind of boundary? Okay. Cool. Yep. Super. Just remember to have the arrows. But we want to, what is it colliding into? Two plates make a boundary, so not just one. So which one is that colliding into? You just draw a simple map. When you have the two plates, and are they going apart, or are they going together, or are they sliding? Yeah, it has to be accurate. So you draw three different maps. Just remember to label what is the arrow. Good. All you're missing is the arrows. Are they going towards each other, away from each other, or are they sliding? So you're just drawing a simple map of two plates and what they're doing. Find two plates that are. Are they going away? Are they going towards? Or are they sliding? This one you're just answering the question of what best fits the creation of Mount Everest. Which interaction? Sliding. What are those two plates? Do you know what continent this is? North America. You know the west coast of North America? Just say this. Of the different boundaries. What are the three boundaries? About 5 minutes. What do you think is happening that causes Mount Everest? What interaction? And why? Why are you picking that? I like, how did you decide? How did you decide that's colliding? Yeah, perfect. You should label what it is.
So I go, so I go to here.
For the, yeah, because you missed just do a new slow model, like a slow model. Of what's the mountain. Just what's happening that causes mountain. But now we've learned some new stuff, so you need to add that. So everything we learned today adds to the idea of mountain building. Yeah, causing what? What kind of interaction is causing Mount Everest? You have slide, spread, or collide. I hope you remember it soon. You know what my mom used to say about it? She would say, I guess it wasn't important. Here's the slip. Okay. African plate and South American plate. Yeah, good. And then level 2 is which interaction makes the most sense for creating Mount Everest. About 3-4 more minutes. And level 3 is updating your slow model. This new information we have. So we have collide, we have slide, and spread. Slide. This is slide. Spread, collide. You could do a whole separate one this time. But like meters out. Yes. So this one, right? Because you're saying up, and this was your first. This is your first guess. This is what you thought was happening. So then here you can start doing a new slow ball. So you can see your learning. It's not bad. The only problem is the fall and the offset is that slow movement or fast movement. Fast does not slow. And the other thing is this earthquake stuff crawls up. But what do we learn today about what's happening with the collide? What's that called? Yeah. So that would cause uplift. I guess you can put in a new page and try to make a bigger one. So you're basically showing why it's not created. If we have slipping and stuff, that'll be fast. Remember, earthquake is fast, mountain growing is slow. All right, about 90 seconds. We're gonna move on. Open it up, please. Running out of room, great. So what do you need to do? Or use one of the other classes notebooks. Okay, then where's your answer to what's causing Mount Everest? And I don't see any like the different types of the valleys. Oh, I see spread there. The spreads when they point away from each other. And then collide is when they go together. Collision, spreading. And then you're missing slide. No, you would need this for a little bit, I guess, if you wanted access to the information. All right, one more minute. The only thing is I would need to draw a line to show these guys, because there's two plates. You see what I'm saying? So a line and two plates are pushing towards each other, and that's all. All right, we're moving on to 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. How do the three interaction patterns differ? What is different about the three types of boundaries? Talk to your partner, please. What's different about the three interactions? Okay. All right, 3, 2, 1, 0. Martine, the three different. What's the difference? So what do you think? What's the difference between the three interactions? So we have collision, we have spreading, and we have sliding. What's the difference between those three things? Abel? 1. Different directions, different movement. The other thing we look at is there's different products from it. Right? We have mountains, we have new floor, we have a lot of earthquakes. Why is collision the strongest fit for Everest and mountain building? Talk to your partner real quick. Why is collision the best idea for mountain? Somebody's back. Why? Not building fucking mountain. Why is collision the most One, zero. Vicente, why is collision the best, the one that makes the most sense? What specific thing do we say when they collide? What is it causing? It's causing something that starts with a U. Huh? If you heard Sophia, she was right. What? It's called uplift. What's it called? A U. And what is the cross section? Let us show that the arrow cases alone do not. So why do we show that cross section and not just showing the arrows at the front? What specific thing are we showing with the cross section? Talk to your partner real quick. Three, two, 1, 0. Mariana, what do you think? Distinguish what? Why? What's happening?
Because like when you're up, I think
Uh-huh.
I'm not sure that you see like the earth more like flat. So
That makes a lot of sense. So it's more three-dimensional. We can see what's happening. Awesome. Cool. All right. Write down 2 questions you think are going to be on the next assessment from today's class. Write down 2 things that you think will appear. 2 questions. Question number 1. Name the 3 main plate boundary interactions. No, just draw it. Two rhyme. We have collide and slide, and then spread. Collide, slide. That's fine. Hi, number 2. At which boundary interaction are mountains most likely to form? Collision, collide, collide. Collision's fine. If you say collision, it's Say number 3, which boundary interaction is a new seafloor most likely to form? And that's spreading, or spread. Number 4, I know it's very hard to see because this is red. I should have done a different question. Or different. This arrow is pointing this way. Here it's pointing up. So if this is A and this is B, which one of these shows the plates moving toward each other? A or B? You just write down A or B. You can't see the arrow. It's a bad picture. So there's an arrow pointing this way. There's an arrow pointing that way. This is A and this is B. So which one is pointing towards each other? So which one of these, either A or B, this arrow is pointing that way. Which one of them is the 2 arrows pointing towards each other? Yeah. And that would be A. This one. And 5, in one sentence, how do plate interactions help explain why some mountains change over time? Think about that word that starts with a U. So we have the 2 plates colliding, that causes uplift. That's uplift. The collision causes uplift. That's happening all the time. The ground is growing and growing and growing. And millions of years later, we have a mountain. Please pass the level sheet up so I can collect them. I need them for the next block. And we'll start trivia here when you're ready. No.